Good morning, good afternoon, and good evening, everyone, wherever in the world you may be joining us from today. My name is Francesco Del Carpio, and I am the Operations Manager at CFAL York. I would like to officially open the 11th and final session of the Drones for Public Health, Safety, Risk, Humanitarian, and Emergency Management Speaker Series, presented in partnership with York University's Advanced Disaster and Emergency Rapid Response Lab and the Southern Alberta Institute of Technology's Center for Innovation and Research in Unmanned Systems. I would like to begin today's session with a land acknowledgement. We acknowledge and recognize that many Indigenous nations have long-standing relationships with the territory upon which our campuses are located that precede the establishment of York University. The area is known as Tekaronto and has been caretaken by the Anishinaabe Nation, the Haudenosaunee Confederacy, and the Huron-Wendat. It is now home to many First Nation, Inuit, and Métis communities. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation, and that the territory is subject to the Dish with One Spoon Wampum Belt Covenant, an agreement to peaceably share and care for the Great Lakes region. As this is an online event and our participants may be joining from various locations, I strongly encourage you to learn about the traditional land upon which you are located. With this, I welcome our moderator, our speaker, and our participants from around the world. Welcome to our webinar. I would now like to introduce our moderator, Michel Arif. Michel Arif is a seasoned geospatial analyst and R&D project coordinator with a strong track record in project management and a strategic application of emerging technologies for disaster risk reduction. She holds a master's degree in disaster and emergency management and has a robust background in applied geospatial technologies. Michel has led and contributed to numerous research initiatives exploring the intersection of climate change, disaster trends, and innovative tools, such as UAVs and remote sensing for humanitarian response. Her work spans global humanitarian efforts as well as community-level resilience building. She is currently focused on advancing local disaster preparedness initiatives, working to bridge technological innovation with practical community-based solutions to enhance early warning systems, response strategies, and recovery planning. Michel, thank you very much for moderating today's session and for your ongoing support throughout the entire series. The floor is yours.
Thank you so much, Francesco, and welcome everyone to our final session for this series. Today's session will be called The Use of Heavy Lift Drones in Avalanche Mitigation. I'm so thankful for everyone for joining us today and those of you who have been with us from the earlier session. We've learned so much together. Just to recap, over this series, we've had incredible speakers that explored how drones support disaster management, Indigenous communities, wildfire response, environmental resilience, humanitarian aid, and even post-conflict recovery. We've also looked ahead at how regulations and new technologies are shaping the future of operations. Now, we conclude with our final speaker, Andy Olesen, who will speak to us about heavy lift drones in avalanche mitigation, which is a fitting way to close this series, showing us once again how innovation in this field can save lives and strengthen resilience. After 3 decades in law enforcement, Andy brings a wealth of experience in deploying response robots across diverse terrains, be it water, ground, or air. Post his tenure in law enforcement, Andy has been instrumental in advancing robotics within the dynamic emergency service sector through active participation in research projects. A key figure in the Canadian Emergency Response Robotics Association called SARA, Andy spearheads efforts to seamlessly integrate response robots into emergency response endeavors. Before we begin, just a quick note that the Zoom chat box is open for communal dialogue. Feel free to connect and comment, share your thoughts as we go. And the Q&A box is also open for questions that we'll take at the end of the presentation. And with that, Andy, the floor is yours. Thank you.
I appreciate that. So we're all familiar with technology. I'm going to hope that this works as
Your screen looks good, but you're muted again.
I'm going to try this again. When I switch over, it seems to be muting my screen. Hmm. So when I switch over and activate the sound, it automatically mutes my speaker.
Interesting.
Uh, okay, you know what?
Francesco, can you maybe Francesco can unmute you from our end when you share.
No, it only lets me mute people. It doesn't let me unmute them.
Well, how about I'll just go ahead with the presentation. I won't share the audio. It's not critical anyway.
Okay.
But yeah, every time I hit share audio, it automatically mutes my speaker.
Okay.
Sorry, it's not letting me. Just checking. Do you see my first slide, explosive charge optimization?
Yes, we do.
Okay. All right. So yeah, apologize for that. Well, I'll work ahead of the audio is not critical. So yeah, thanks everybody for being patient for that, and I appreciate being invited to this group. One of the things we've learned over the years is just working in silos is not productive. You have to reach out to different groups, and working together with groups like York is a big benefit to us. So thanks for that. So I'm going to talk a little bit about this project. The title of it is Explosive Charge Optimization for Drones for Avalanche Risk Mitigation, which is a mouthful, I know. So I'll get a bit into my background and what the project is. So that's basically the title. We're working with the Defense Research Development Canada on this project. That was the title we came up for it. So it's kind of a very formal sounding title. Our Canadian Emergency Responders Robotics Association is a group we started a few years ago. It's focused just on public safety agencies because we found, as much as there are a lot of good groups out there focused on technology, um, the applications we have are very specific and unique. So we formed our group for just that purpose. We have an excellent relationship with Transport Canada, Nav Canada, and we also deal with air, ground, and water robot systems. So simultaneous with that, I thought I'd do almost maybe two presentations in one. So I've been fortunate. I'll get into my background. I've been fortunate to a lot of very unique, sort of forward-thinking projects, and there was a lot of lessons that I've learned on the way that I wish I could have learned early on. Whenever you do something different, you're going to be up against some challenges, and everything around us at some point started as a crazy idea. The cars, computers, lights, the cell phones, everything we're using now was somebody's idea, and a lot of people didn't see the potential of it at first. So what I found with the projects I've been doing is number one, you have to be mentally prepared. You're going to come up against some serious challenges. You're going to come up against people who are going to critique you personally. They're going to critique your project. Good criticism is completely valuable, but you got to be prepared for it. You got to be very resilient. I think it's also important that you can't underestimate any experience you have. I was fortunate. I did a ton of stuff in my career. I've done a lot of stuff since, and I know I meet people, and they almost don't understand if they do a lot of different things. They don't understand what value they bring. But there's a good chance that whatever challenge you have, the solution is probably going to come from somewhere else. So having a wide variety of experience, connections, background for any project is extremely valuable. If it were easy, it would have already been done. Like I said, everything around us, we can look at computers, cars, cell phones, and say, right now, that was a great idea. Not so easy to go back years or decades ago when somebody first came up with the idea for a cell phone and say that was a good idea. So you've got to sort of begin with the end in mind. And then also, this is my term, I call it the spider web effect. Whatever idea you have and project you're developing, you have to know that it's going to open up other doors. You're going to start seeing other areas of opportunities, things that you could not consider until you started on step one. It's important to keep focused on the project, but you have to be aware of these other opportunities, and either you integrate them into your project or you just kind of put them on the side burner, and when you have time, you go back. But there's huge interconnectivity in all these projects. So a little bit of background on me. I spent 30 years in policing. Was fortunate, did a lot of cool things. I started in the Marine unit, spent patrol, bikes, everything. So I was working with underwater robots. Was on our bomb team and our chem bio unit. Spent a lot of time in bomb suits with bomb robots doing various things. Since I've left, the picture on the right there, we were doing some wind tunnel testing with drones just to see their capability. That was up in Ottawa, at the research center. The pictures at the bottom, I was fortunate to go down to do some use some drones to do damage assessment at an island in the Caribbean, St. Vincent, about almost exactly 4 years ago now. So that was a lot of lessons learned that I brought from that. The picture at the very bottom, actually my partner and I, Darren, we had hiked up. The volcano had exploded or erupted in like April. We were there in August, so just a few months later, and we spent 4.5 hours hiking up to the top in terrain like that. We got to the top. We took our drones with us in backpacks. We got to the top after a grueling 4.5 hour hike, and we got there and we realized it was far too windy to fly. So we spent about 15 minutes up there and hiked down. As we're hiking down, we had a guide with us, but the guide was the area that you see there was a full forest a few months earlier. So he was used to the forest and the trails, and it looked nothing like that. So we got lost a few times. He lost his direction. So my partner there actually had a smaller drone with him. So he popped the drone up in the air and we were able to see the trail we were supposed to be on a few hundred meters from there. But it's just a very valuable experience. And also I found that perspective is everything. Like I said, I'll get into the sort of the details of some of the projects, especially the Avalanche project, but just a lot of lessons from all the things you do. So this was the same St. Vincent trip. If you don't know, St. Vincent is a Caribbean island, maybe about 15, 20 minutes flying from Barbados. Not a very wealthy island. The United Nations is there because they support it with food programs. Just not a lot of resources in the country. So it was interesting. We went down there as a couple of Canadian, well, there's about 5 of us, but a bunch of Canadians who are used to, nice cars, the latest cell phone, fancy clothes, all that stuff. And it was pretty humbling when we went down there. Like I said, the island's 20 kilometers. When a volcano goes off, they knew it was coming, but there is nowhere to go. So these people, they knew it was coming, they were prepared, but they just had to basically ride it out. So the picture on the bottom corner, we were out flying the one day. We were there, I don't know, maybe a half an hour. And a gentleman came out from the house, really nice, and he offered us some water or some just anything we needed. And after talking to him, we realized it's tough to see in the house, but a few months before, after the avalanche, that house, there was basically, you can't see it, there's a gray line that starts about halfway, goes from the halfway point down to the ground. That was full of volcanic ash. So we're used to snowfall here, and the snow piles up and we shovel it and we complain and swear, but eventually it melts. The thing with volcanic ash is once it's there, it's not going anywhere. So his house was surrounded by ash and he had to basically shovel it to the side. So he spent weeks shoveling it. And then we found out that his wife was ill, and they'd lost their power and their water. So every single morning, this man would walk about a mile to get water to come back, or groceries, whatever he needed to come back so he could look after his wife. So after all that, he had no power, no water, hiking a mile back and forth to get it. And all he could do was think of ways to help us. So it was pretty humbling. And then the kids you see in the picture there, every time I see them, I get a little emotional because it's the same thing. Like our kids here are used to so many different things. They had nothing. Like they had a bike they shared because it was bought for them by a Canadian relative, but just the nicest kids you'd ever want to meet. And we come down there with our fancy drones flying around. They were so curious, and basically gave them a quick lesson on how to fly the drones, and they adapted so unbelievably quick to understanding us. Like I said, it was a really humbling experience. These people had gone through a lot of different things, but their outlook was just so amazing. So like I said, I left policing in 2018. I've been involved in a bunch of projects with our Defense Research Department, all revolving around exploring new robotics in the emergency service field, counter explosives, counter drone, all that sort of thing. One of the first projects we got involved with was, if you're into technology, you've probably seen some of the new four-legged robots coming out. So we got one of those to evaluate for a year in emergency services. I'm not sure how well the video is going to play, but one of the things we wanted to do was, we're used to the wheels and the tracks on robots. That's what most of the robots, especially in the bomb field, that we know, use. These new ones have integrated technology. They have computers that do much of the thinking and navigating. Basically, the human just pushes forward and decides where they want to go. So working with an agency in the States, we were developing, this was during COVID, so we were developing new test methods. Hopefully this plays, but so it would be something as simple as milk crates. This system had various degrees of success. As much as it looks like it's stumbling, it actually did really well on this because the wheels and tracks that we're used to could not have tackled this at all. And this was simply the operator pushing the stick forward and the robot would decide where it's going to go. Fast forward to November of 2023. So I was giving a presentation for a large group of industry. These are the people in the oil and gas, the rails, all the ones that deal with large scale response. So if there's a train derailment, if there's like a huge chemical spill, these are the people in industry that go out and they might have to build a road. There's no roads. They might have to build a road to get to where the derailment is, or they might have to build whatever it is. Sometimes it takes money, but it takes a lot of resources, but they have to act quickly. So after my presentation on drones, somebody from the explosive industry came up and he said, have you ever considered using drones for avalanche mitigation? And honestly, like, I dealt years with drones. I dealt a lot of experience with explosives, but I knew nothing about avalanches. So if some of you are familiar with it, then just let me know if I make any mistakes. But one of the key areas of avalanche control is basically to destabilize the weak snow layer. So you have a mound of snow that progressively builds high up in the mountains, and it could be a threat to a road, it could be a threat to skiers. And the idea is, in a controlled way, you want to release all that snow. You don't want it coming down when there's a bus traveling through the road. You don't want it blocking the road. Loss of life is a big deal. But if it blocks a road, then in some of these areas, you're looking at literally millions of dollars an hour that impacts the economy. So what they use is a bunch of different, usually explosive techniques. I'll show some of the current techniques that are out there, basically to trigger those amounts of snow and in a controlled way. So they can close the road down. They pick the time and the place to initiate that avalanche in a safe way. The snow comes down. If they have to clear the road, they do. But it's all about doing it safely in a controlled method. There are a bunch of techniques, and we're talking about Canada, but any country in the world that has mountains, has skiers, has roadways. The United States, avalanche mitigation is huge. Italy, Switzerland, Argentina, pretty much you name the country that has mountains and roadways, they're doing some or all of these techniques. So some of the techniques are, if you can see on the slides there, some of them involved artillery shells. So in our case, our Canadian Armed Forces have positions in British Columbia where they have pre-stationed artillery guns. They'll fire a shell into the side of the mountain to initiate an explosive. There's also different kind of tower mechanisms. So these, as you can imagine, it's a lot of logistics. They're expensive. They're in a fixed location, and basically at a predetermined time, they'll release whatever explosive mitigation charge they have or technique onto the snowpack below to trigger an avalanche. In some of the smaller cases for ski hills, ski resorts, it might be a ski patroller with small amounts of explosives in a backpack. They'll light it and throw it to initiate smaller avalanches. So what we've learned since then was helibombing is the most popular or the most effective method for avalanche control, just because it has a high degree of flexibility. And it's pretty much what it sounds. You have a helicopter with a crew. They take an explosive charge. In that charge, There is a safety fuse, which if you're familiar with fireworks, it's similar to that, where you light the firework, it burns for a certain amount of time, and then the firework goes off. This is the same. So I'll have these bags of ammonium nitrate fuel oil. You can see in the one picture, there's these the two little red strings. So those are safety fuses. So it'll be lit. In this case, it burns for 2.5 minutes. They throw the bag down onto wherever the avalanche target is. The helicopter will back off. Hopefully, the charge goes off and initiates the avalanche, and then they move on to the next target. So it's very safe. They've been doing this for decades, but there's always danger. As soon as you have any kind of explosives, people, these kind of situations, there's always a risk of danger. This was a helicopter crash that happened in BC and British Columbia just a couple of years ago. The crew survived. Sorry, but what happened was when the charge went off, there was a huge cloud of snow. The pilot became disoriented. The tail of the rotor struck the side of a tree or the side of the mountain, and the helicopter came down. So in this case, there was no loss of life. That's not always the case, unfortunately. But losing a helicopter is obviously a big deal. It's expensive. So you can't not do it, because not doing it means you have heightened avalanche risk. So like I said, what they do is incredibly safe, but no matter what you do when you're dealing with explosives and people in this situation, there's a possibility for hazards. So what we had to do first was we had to figure out what we didn't know. Nobody is really doing this stuff. There's a few companies, a few agencies out there that are sort of in the first stages of avalanche mitigation, but there's not a lot out of there. So we didn't have a whole lot to draw on. So at the start, we had to select what type of drone we're going to use. Most of the drones, I don't know if there's any drone operators out there, but most of the ones we're familiar with are fairly small. The ones we're looking at have to be able to carry 25 kilograms or more of an explosive charge. The operating conditions. So we're not just flying over fields. We're in a mountainous area. So we have mountains, we have winds, we have temperature. There's a lot of different things to consider. Regulations. The regulations currently do not really exist to do this kind of operation because nobody's doing it. We have a really good relationship with our federal regulators, Transport Canada, and they saw the potential for this early on, that it was a benefit. So they've been really good about working with us within the regulations to try and advance this capability. And then the operations too. So like I said, this isn't just flying around, doing mapping or taking pictures of buildings. There's some pretty serious stuff involved. You're looking at large amounts of explosives in a very dynamic area. Lots of things can go wrong. So we had to write that into our operational plans. So what we did was we went through a series of identifying which system was going to work for us. The heavy lift drone, drones have been around for decades. These types of drones are pretty recent, and the capability to do what we want to do with these is even more recent. So we had to look at things like operating temperature. It had to be able to operate in sub-zero temperatures. It had to have a wind tolerance. In this case, the system we selected came with a parachute. It came with ground terrain sensing. So we had a really good indication of where we were in relation to the ground, because that's important. It had a lot of different redundancies, fail-safes if something goes wrong. If we lose control, we have to understand what's going to happen. So we put a package together and we submitted it to the DRDC, as the Defense Research Development Canada. That was our 7th project. We've done a lot of cool things. This one got the most attention of any project we've done. Our contact there was actually involved in some of the avalanche mitigation in British Columbia and knew full well some of the challenges and hazards. So they were very supportive of us. Hopefully this is going to play. So like I said, there was a lot of things we didn't know. We didn't know, like, payload dynamics. How are different payloads, different sizes, shapes going to react in different environments? How's the wind going to affect different payloads? How can we deliver a payload? How accurately can we deliver a payload? Can we release the payload? It's one thing to get some kind of a package from point A to point B, but when you get there, how are you going to release it? So hopefully this video plays. So we were at a fire training center I'm in the Toronto area, so we were not far from Toronto. In this case, we are going to go and pick up a basically like a rescue stretcher. Obviously, it's not explosives, but that wasn't the point. It was to understand how we're going to hook up these payloads, how different payloads behave. So hopefully this one plays, but we'll see. So in this case, this is the DJI Flycart 30. So the system, obviously we launched, and now we're going to pick, this is all in very short range. So now we're going to a pre-positioned site to pick up the rescue stretcher. That's the winch coming down. This isn't professional video, so I apologize if it seems kind of choppy. So some of the things we're learning is ground crew positions. You can't just have anybody on the ground like this. You have to have briefings. There's a lot of hazards. You have a big, expensive, heavy drone overhead. How are you going to hook up the payload? Communication back and forth. So we learned a lot about wind dynamics with this. The payload has a certain weight, which was under the capacity. If the wind got too strong, it would blow on that stretcher just like a sail, and it would increase our payload. So we had the potential to go over our payload limit. So that was a good lesson learned. So now we're just maneuvering over, and the idea behind this is to deliver it to a very small area to somebody waiting on the roof. This is all filmed from a second drone, if you didn't know that. So again, a lot of this involves things that you don't really realize. Like there's a lot of communication involved between the person operating and the person who's going to receive the payload. This one was relatively simple, but we were able to obviously drop it in a very confined area. And the payload releases and the drone flies away. So another one we did, this was in Mississauga near Toronto, Ontario. So we're at a water treatment plant. This one's probably going to sound a little bit crazy, but underwater robotics, remote operated vehicles are another area we deal with. So we wanted to see what would happen if we hooked up basically an underwater robot and delivered it to a water surface. So this presented some challenges. One of the first ones was it's a $75,000 underwater robot. We were going to transport it over, it's a short distance, but basically over pavement. So if the connection wasn't right and it dropped, we probably lost a $75,000 robot. So big thanks to Deep Trekker, who was the company that provided it. Another challenge was, unlike most robots or drones, underwater robots have a really long tether. They can't operate without being connected. So there's a really long cord that goes from the robot to the controller, and it provides power. It provides the video connection link so that you can see what the robot's seeing. It provides all those. So as we're going through this, there's a lot of pre-planning, a lot of pre-discussion on how we're going to do it. What happens if the cable gets caught? What happens if the system doesn't release? So I'll play this video. So that's our crew member on the ground there. He's actually a member of Deep Trekker. We had a lot of briefings ahead of time, how we were going to attach it. The means of attachment is important. So he makes the connection. He signals to the operator. We did a couple of tests low level on land before we did this, just to make sure of the connection. But now the drone flies up. So we're flying into this is a water treatment plant. So we're flying into one of the water treatment ponds. It was one of the good ponds. It was at the end of the process, so the water is pretty clean, which was something that was really important to us. Now we're going to deliver the drone into a water environment. So you may wonder, like, how does this relate to avalanches? But it's all about understanding payload dynamics, the what ifs. Now we're dropping it into a water target, so the dynamics are much different than they would be on dry land. And until we did it, we weren't 100% sure if it was going to release and how, but it did really easily. And then one of the final ones we did before our proof of concept. So we were in Edmonton. A friend of mine runs the Edmonton Police Bomb Unit. We're at their training center. So this was, we were taking the fly cart and we took a bomb robot. And one of the vehicles they have there is a highway coach bus. If you think of like the GO buses or any of the highway buses, they're big buses. They have these roof access panels. So what our concept was, if that's your only means to get a robot into a vehicle is through the roof, could we do it by drone? So this is the fly cart, which is fairly large system. It's a bomb robot, and the whole concept of this was to fly that up and drop it in a little small access. So I'm not flying this. I'm actually in the bus filming it through the roof hatch. It's too bad the sound's not on because it sounds like a helicopter overhead. So like that robot is obviously too big to go down the aisles. There's smaller robots, but that's the one we had. So the important part for us wasn't so much the robot, it was the process. We table talked this. We walked through all the what ifs. What if the robot doesn't fit through? Well, we knew it was going to fit through the hatch, but what if it gets hung up on the hatch? What if as we drop it, the winch line gets hooked up? We now have like an 80-kilogram drone overhead with an expensive bomb robot, and it's now hooked to the bus. Like, what are we going to do? So we walked through all the what ifs we could do, but at the end of the day, we just had to do it, and it actually worked out really well. That was our first attempt, but it was a first attempt after a lot of practice doing other things and understanding. So a lot of good takeaways for us from that. So hopefully this plays. So this led to our first trial in Pemberton, British Columbia, is about 2 hours north of Vancouver. I know Wade, who's on the call, was there with us. So basically the stakeholders we had there was our primary partner was the British Columbia Ministry of Transportation. They're the ones on the roadways responsible for all those avalanche mitigation techniques that we mentioned, the towers, the helibombing, all of that. They're responsible for it. So they were our stakeholders early on. We also had, like I said, Wade, Southern Alberta Institute of Technology was there. We had some of our members from SARA who come from the policing and fire agencies, which obviously bring a whole wealth of experience. There was a bunch of people that kind of made this happen. So we went up there, and the whole purpose, we weren't delivering live explosives. The whole purpose was to say, can we take a simulated explosive? So you'll see in a second, it's basically it looks like a big bag of cat litter. It's similar to what you saw in the helicopter. So same sort of shape, weight, dimensions. Could we lift it from the ground and deliver it to what would actually be an avalanche target? So I'm going to play this. You're going to not have the sound, unfortunately, but. This is part of the pre-briefing team. We had drone operators, helicopter operators. So this is an avalanche mitigation, like an actual site they do avalanche mitigation on. There wasn't the need for actual mitigation at this time, but the site was genuine. And then at the end there, I'll kind of talk about that in a second, but that was the LiDAR. So LiDAR is light detection and ranging. It's a way of, right now they use it for mapping. What we found in what we're doing is we are going to start doing sort of pre and post blast avalanche assessments. So before the charge goes off, we're able to do assessments of what the snowpack is. Afterwards, we do another sort of three-dimensional assessment to see what the results are. And it had the added benefit of if for some reason the drone loses communication, it can provide a navigational ability. So after that, we basically tallied up the results, did all the discussions with our stakeholders. The response was overwhelmingly positive. They said it's probably the biggest advance in avalanche capability in decades. So that was all using inert, basically non-functioning charges. So we made a proposal to our, again, the Defense Research Department for a 2-year project. The next project focuses on using live explosives. So the next steps are this fall, we're going to engage with, in our case, our federal government has the Canadian Explosive Research Laboratory. They do all the explosive testings. So what we found is there's a lot of information on explosives and aircraft, like aircraft drop bombs, whatever they're doing. There's a lot of data on that. There's almost none on drones and explosives. So we have to start capturing that. Part of the reason for that is we're looking at new explosive delivery options. So rather than just letting the charge hit the snowpack, can we let that charge go above the snowpack? That air blast option could mean a dynamic change in avalanche mitigation. It might mean, until we do it, we don't know, it might mean fewer charges, more effective charges. But we have to go through all this stuff to get the data so that we can get the approval from Transport Canada. One of the things we have to do is emergency procedures. If a drone with 25 kilograms of explosives or any explosive flies away, that's a bit of a problem, right? So it's, how do you train the crew? This isn't just normal flying. There's a lot of responsibility, a lot of things that can go wrong. So we're also working through that. And then constant communication with the stakeholders. So in our case, the stakeholders are in the British Columbia Ministry of Transportation, the people responsible for this. It's Parks Canada, it's Canadian Avalanche Association, it's our Defense Research Department. There's a lot of groups and agencies that have a vested interest in kind of what we're doing with explosives and drones. And equally that we found out it's a high interest in other agency countries around the world. So our 2-year project, right now we're focusing on, like I said, those explosive trials in the fall, which will give us our licensing, our ability to carry explosives. In the spring, we're going to do some trials, ideally at a quarry site in British Columbia. It's just that step-by-step process. So the explosives will be in a very secure area. We control it. We can ensure safety. After that proof of concept, then in about 2 years' time, the plan is to go to an actual avalanche site, deliver actual charges, and ideally have an actual mitigation effect. So like I said, I've been fortunate to do a lot of projects. A lot of lessons learned along the way, a lot of things I wish like I had learned or people had told me. So I hope it's of value, but I just thought I'd share some of them on the way. A couple things. One, where you start is very rarely where you're going to finish. Just like this, even throughout the course of a year, I know Wade from Southern Alberta Institute of Technology was a big part of this. Where you start, it's going to adapt because nobody's been before you. So you have to be able to change what you're doing. You have to accept failure. Success is great, but you're going to learn a lot from failure. As long as it's constructive failure, that's a big part of the process. So you got to, if something goes wrong, you got to try not to be discouraged. You take the lessons learned from that, and that will probably move your project further. It'll also support you in every other project you do. Clarity emerges through action. We usually have a pretty good game plan of what we're doing. Like I said, whether we're delivering an ROV in the water, a bomb robot in a bus, we had a good idea of what we wanted to happen. But at the end of it, there was a whole bunch of lessons learned. So it comes back to where you start isn't always where you finish. And until you actually do it, that's when things make sense. Try and keep it simple. The more complex something is, the more likely something's going to go wrong. So just like simple steps, prove the concept. it's a lot easier to explain something simple to somebody than it is something complex. Collaboration beats isolation. I can tell you so many groups who try and keep things to themselves. They don't want to let the secret out, but they also rarely succeed. You need other input. You need other ideas. You need to talk to people, not just from your own industry, but from all the other areas, academia, government, emergency services, industry. You got to be flexible. Your starting plan could go either way at any time. Technology doesn't always work. Batteries don't always charge. So you have to be flexible. Small wins build big momentum. None of the projects we didn't succeed day two. It was all about like setting small objectives, learning from them, achieving a success, and using that as sort of a building block. Communications is important, not just at the start, but all the way through. I know, like I said, Wade and I talk to the Ministry of Transportation in BC all the time. We talk to our Defense Department people all the time. The why outweighs the how for sure. You have to understand like why you're doing something. The how is the easy part, but understanding why you're doing it is critical. And I think the biggest thing is growth mindset is everything. If you're part of something important, you know it's going to be a big deal. You got to kind of begin with the end in mind. That's a very important thing, and it's going to help you overcome all the little challenges and setbacks and things that don't go wrong if you have that sort of big picture of what you're doing. I'm going to stop sharing now because hopefully, I think I have sound still. You can hear me, right?
Yes. Thank you, Andy. That was a great presentation. I know people probably have lots of questions. They're just trying to take it in. That was a really well like phrased, I guess, presentation. Is very easy to follow along. If I know Wade's in the panelist, if he wants to jump in at any point, feel free to, Wade. I know he's been involved in some of these projects. I can kick off with some questions if I'm just while I'm waiting for some of the other ones to pop in. So one question I had was, when you're looking at an area, like a potential avalanche area, how do you measure the destabilization, I guess, factor? Can you do that with drones as well, or are you using traditional methods to locate and pinpoint which areas you'll target for, I guess, the mitigation or for the spark?
So for us, we don't get involved in that part. We would leave it to the stakeholders, which in this case is the British Columbia government. So they'll make that determination. Our whole objective is just to prove that you can use a drone to deliver a charge. And right now, the charges are based on what they're doing now. But ideally, if we can create new methods of delivery and new charges so that we use less explosives and they're more effective, that's sort of our end objective for all this.
Okay, so you mentioned you use LiDAR. Is LiDAR used to determine the effectiveness of the spark at the end, or is that just to like kind of locate where you're placing the spark?
So right now, that's sort of a new capability. Right now, LiDAR is used a lot in 3D mapping, in industry, commercial programs. We're using it in avalanches, so that's part of the testing. We're going to be doing that in the next couple months when the snow comes, is to do that pre and post assessment, to use that technology to see just how effective we are, not just in our operations, but general avalanche mitigation. And then it also has the added benefit when we were there in December, the system we were flying, it can provide a navigational means. So if the drone loses connectivity with the satellites, it can provide sort of an autopilot to take the drone back to a safe location. So it provides that extra level of security.
Mhm. Okay. We have a question from Emmanuel, kind of along the same lines of LiDAR. So he says, "Hi, great presentation, and it is really great research jobs. How would you apply LiDAR?" Exactly what you just answered. As fast-paced seek and rescue, which range are you looking for? So I think they mean which LiDAR range, but if you want to add anything more to that, feel free.
Yeah, I'm the first to say, like, I'm a techno geek, but I'm not a LiDAR geek. So we have people that know far more about LiDAR than I do. I think like Wade knows far more about LiDAR than I do. So we're just sort of seeing how we can take these different technologies and make what we do better, more effective. So that's part of the process that we're in.
Mhm.
Yeah, great job on the presentation, Andy. I think that's part of the research. That's part of the question is what we'll be utilizing a few different types of LiDAR sensors that allows us to fly low to the ground, but also fairly high to the ground. The drones that we'll be leveraging will offer different both endurance and distance. So we'll be testing that as well over the 2 years. So it's going to be really a demonstration of what can LiDAR do, what types of sensors are worth using at different price points, because we want it to be scalable, and then also endurance, drone endurance, payloads, detect and avoid systems. So yeah, it's going to be an interesting project.
That's great. It's definitely been a long time coming, so we've heard lots about it over the years. Dr. Asprey, if you want to jump in, feel free to. I think you had a question.
Sure. Thank you very much, Andy. Well, certainly, I think this application is one of the most challenging and complicated drone operation within the field, and I really appreciate and understand some of these challenges that you have been trying to resolve. And I have some questions, but I really want to appreciate the work that has been done so far, and looking forward to see the outcome of the decision, also tests that you will be doing. With regard to the drone payload, I noticed that you have a drop-down payload. Is there any specification in terms of how much distance, or what is the length of the rope that you attach the payload or the explosive to it? Is there standard, or?
No, that's actually a great question, and that's what we're going to be engaging in with our Canadian Explosive Research Lab. Because if we carry an explosive, number one, if for some reason the explosive goes off while it's in the air, how does that affect the drone? At a certain distance, it's probably not going to have effect. But the closer, like if we're carrying it 10 meters below the drone, it's probably going to cause the drone to crash. What we're looking at is, would a distance of 50, 60, 70 meters, if we can transport it at that distance, ideally what we want to do is detonate the explosive while it's attached to the drone. Because two things will happen. If the charge goes off and we cause the avalanche, that's a good thing. If for some reason the charge doesn't go off, we can just return it to a safe spot. We don't have to leave a live charge on the mountain. So what happens right now is most of the charges go off. They don't always go off. So if a charge doesn't go off, they have to throw another charge onto the first charge, because you don't want to leave a live charge on the mountain. So that's exactly what we're kind of exploring this fall, is what is that distance that we can transport an explosive. I think it's going to be in the 50, 60, 70 meter range. But we don't know. That's an interesting part about this. There's no data out there on that. And literally, I had a meeting 2 days ago with our Canadian Explosive Research Lab as we develop what the test methods are going to be. So we're going to go to Canadian military base in Ontario and conduct these tests in the fall. But sorry, that's kind of a long-winded question, but that's exactly what we need to know.
Mm-hmm. That's very good. Thank you very much. The answer is quite interesting. And this actually answered the second question to some extent that I had, which with regard to the detonation of the explosive. My question, I should probably correct it now, but the question was about what happens to those explosives that are not, activated once released. But probably from what I heard, you activate them or detonate them before by the drone or by the operator before they are released. Is that correct? It's not that the case that they are detonated once they reach the ground.
So what the current method is, so they light the fuse in the helicopter, they throw the charge out, the charge will burn for about 2.5 minutes, and then it detonates. What we want to do is have that charge connected to the drone and then detonate it remotely. Because right, it's like if you light a firecracker, you have to let it go. Like you can't stop it. It's the same with these helicopter charges. They're still safe, but you can't stop it. What we want to do is have that absolute last control down to the millisecond. So we're holding the charge. If for some reason we don't want to detonate it, we don't have to. But if you do, we have a secure remote initiation method to do it.
Very good. Do you do any simulation on this? Because I think there are rooms for simulating all these, especially with regard to the length of the rope and other things.
Simulation, no. The tests we're going to do will be live tests.
Live
So we're going to have
tests.
like explosive pressure sensors and different charges and different lengths of rope. That's been a huge part of the discussions. But like computer models and stuff, if there's stuff out there, I'm happy to look into it. I don't know.
I think there are really good potentials for that simulation to help the actual test or help with the test. Thank you. I stop here because I'm sure there are other people who want to ask questions.
Yeah, I could just add there on the simulation side, part of the project is to build some training curriculum so we can actually train operators to basically operationalize the project. And as part of that, there would be some simulated training along with, utilizing a winch and actually flying to a location that might be mountainous and challenging. But yeah, we hadn't thought about the integration of the simulation into the actual research. So that might be something we look at later on. Thanks.
That's honestly, having done these projects, the hardest part is we have to come up with a concept over a year or 2 years without any idea of what the end result is going to be. And usually a month or two in the project, all these new areas come up that we couldn't have anticipated. So that's exactly the case here. These good ideas come up and we have to somehow try and fit them into our work plan.
Great. I have a question. Do you think that this drone-based avalanche mitigation will one day soon kind of outpace traditional methods, or do you think we're still far away? Like it's a long way to go.
If you ask me, honestly, I think it's going to quickly change a lot of things. I think these large drones in general, like we were working in areas like Niagara Falls. They do a lot of, there's areas in Canada where they will not send a human and a helicopter can't reach it. So part of our process is to look at these kind of drones to be able to go in where nobody else is going to be able to save people. So those kind of applications have come out of our lessons learned from all the stuff we're doing for the Avalanche project. So I think absolutely it's going to change avalanches and just a lot of emergency response.
And you said that you were part of like the Canadian research group. Are you in touch with, I know you touched on other countries which have mountains and avalanches, things like that. Are you in contact and communication with how they're doing this kind of research and how far they've gone along in this area?
Yeah, so the United States and Alaska are doing some. They have a slightly different approach and a smaller drone than we're doing. But as far as working groups, I just got off a meeting a couple hours ago. So talking to people from Australia, Norway, Poland, the UK. So there's sort of a big sort of network of people, and we're all sharing lessons learned. It honestly does not matter what language you speak or what country your flag is. We're all kind of sharing the same lessons learned for these experiences.
Great, thank you. That's a great answer. Okay, if there are no other questions, I think we can wrap up this session. I just want to say thank you so much, Andy, for this incredible session, and I think we all learned lots. Thank you again to our hosts, Dr. Asbury, Wade Hawkins. I know we've done lots together in the past, so it's been great. Yeah, I'm just echoing the thank yous that we're getting in the chats as well. But if anyone wants to reach out to you, is there an email address that we can pop on screen, or how do you?
Yeah, you can share the email I sent with you. I probably should have included that in my presentation, and I didn't. So sorry about that. But yeah, no, feel free to share my email.
Okay, I'll do that. Well, thank you so much. I don't know if Dr. Asbury, you want to wrap it up? But,
All right. Thank you very much, first of all, Michelle, for all the hard work and support for this speaker series, working as not only the moderator, but also communicating, bringing in speakers from different areas, and of course, Wade for said contribution to this speaker series, without which we couldn't mount and run this a successful speaker series from CFAL York perspective, and this has been a very enriching experience for I think all the participants and ourselves in hopefully creating an environment for drone operations activities related to humanitarian disaster and emergency management, and those who are interested in this area. I'm sure, for example, this case of Avalanche application, there are lots of life lost in many different countries because of that, and this is hopefully a technology that can help minimizing those impacts, and like many other applications that we discuss here in this speaker series. All said, this is not the end of this sort of thinking and conversation around. We hope to come back with a new round of a speaker series, which also brings in drone applications in this area, but more specifically in one of these, and perhaps specifically for Avalanche operation in the future. And thank you to all the participants who have been with us for the past few months and so forth. I also want to give a floor to Wade for your last comments, points, and anything you want to add. Thank you so much.
Thanks for that. Yeah, I echo your thanks. Thanks to Michelle for doing an excellent job on leading the sessions, moderating, helping to plan the speakers as well. Ali and Francesco and the folks at York. It's been a great partnership, and yeah, I agree. I think we'll be sitting down and revisiting, what the next year looks like for a speaker series standpoint, and trying to get more engagement and more interesting talks and impactful presentations. So thanks. And thanks to my team here at CIRRUS, the Center for Innovation and Research in Unmanned Systems, just to help support the presentation sessions. So, and Andy, great job today.
Absolutely.
Thanks,
yes.
I really appreciate the invitation. Thank you.
Yep.
Thank you.
Over to you, Michelle.
Yep, that's it. I'm just gonna wrap up. Yeah, we're
All right.
out of time. Thank you, everyone.
Thanks.
Have a great day.
Thank
Yeah.
Bye.